to configure it to you, and I would like to thank you so that Eigrp can work better for the network. We will also talk about how to troubleshoot Eigrp if something goes wrong with the Eigrp. So I have this topology which I'm going to use for the Eigrp configuration and troubleshooting part. And then we have this objective in mind. So we have the lab objectives. You can see like we are going to configuring Eigrp for the given network. Then we have some task to complete for that particular network. So we are going to follow the same task, and we'll try to configure the Eigrp according to the task. Now in this particular topology, I have also added one troubleshooting section which will help you to understand how to troubleshoot Eigrp from a CCNA certification point of view and from the real world point of view as well. So as we know that when you go to write the CCNA certification, then you will get two simulations in the real exam which you have to do. So out of those two simulations, one will be on Eigrp. So Cisco will ask you to troubleshoot Eigrp. So I'm gonna to do the same kind of feeling which you'll get in the real exam. So that's what we'll do here, troubleshooting. Let's get familiar with the topology first. We have two remote sites, which is remote site number 1 and 2, and this is my backbone router. So router number 1 has two connections going to router number 2 and router number 3. I have configured different bandwidth according to the link, so that Eigrp metric will make one link as the best link, and it will make another link as the a feasible successor, if I need to say in the technical terms. So one will be the best path and second will be the backup path, which we will be able to verify with the help of the show IP Eigrp topology command. So this is our topology. So route number 1 has a bunch of loopbacks. I have also labeled the IP addresses according to the interfaces. So I have configured all those IP addresses, the basic IP addressing, already on all the routers. So you don't have to or we don't have to actually configure IP addressing. We can move to the Eigrp configuration directly, and we can verify the Eigrp as well. So let's go ahead and look for the task number 1. So lab objective says that configure Eigrp autonomous system 200 for the given network. Make sure that it does not summarize to the classful boundaries. Okay, so we're going to use AS number 200 on all the routers, and the lab objective said that it must not work like a classful routing protocol. So by default, RIP and Eigrp will try to summarize the networks up to their classful boundaries. Like if I need to advertise 172.16.0.0, then the router is going to advertise these networks as /16 to router number 1 and router number 3, because that's the by default summarization which happens in Eigrp and RIP. So we are going to disable it, as lab said, with the no auto summary command, and we will advertise this. So let's go ahead and on router number 1, and I'm gonna say global configuration mode, and I will say router Eigrp 200, which is my autonomous system. I'm going to disable no auto summary, which will disable the automatic summarization, and I'll say now network 172.16.0.0. so I can stop it there because this is a classful network statement. Now the key point about the network statement in the Eigrp world is that you have two ways by which you can put the network statement. Either you can use the classful network statement, or you can use a network statement with the wildcard bits. If you want to use wildcard bit, which means that you have the flexibility to advertise a specific network into the Eigrp process, but if I say the network 172.16.0.0, which means that it will advertise all those networks starting with 172.16 into the Eigrp process. Now apart from that, network statement does two things in the Eigrp world. Number 1, it will start sending hello messages out of all those possible interfaces which you have. Like it will start sending hello messages on all these 4 loopbacks, and it will also advertise these networks into the Eigrp process. So these two things which the network statement does. Next, I'm also going to use the wildcard bit now, so you can see that how does it work. So I'm going to say 192.168.0.0, 0.0.255.255. In wildcard bits, 0 means care bit, where 255 means do not care bit. So here if I say only care about the first 2 octets, so they must be 192.168, but don't care about the last 2 octets. So anything starting with 192.168 will be advertised into the EIGRP process, and that's what we want, because both these IP addresses are starting with 192.168, and that's what I said in the network statement. So that's it. Now I didn't see any neighbor relationship coming up because I did not configure EIGRP on other routers yet. So let's go on router number 2 and router number 3 and configure the EIGRP also. So I'll say router EIGRP 200 because I'm already in the global configuration mode. I'll say no to summary, disable automatic summarization, and I'm going to say network 192.168 dot, which network is that? It's 2.0, and I'm also going to say anything starting with 10.1, please advertise that into the EIGRP network. So now we can see that we have a neighbor relationship coming up. Now let's say if we are learning some routes, so if I'll say show IP route EIGRP, which will only show you the routes which you have learned from EIGRP. So sweet, I'm learning few routes from EIGRP D distance. If you see D in front of any network in the routing table, which means that you have learned that route from EIGRP. So I have learned all those loopbacks from EIGRP. I'm also learning about 192.168.1.0. 90 is the administrative distance of EIGRP. Now the administrative distance is the reliability of a routing protocol. Less the administrative distance, more reliable the routing protocol is. So the most reliable thing in the Cisco world is a directly connected network which has an AD value of 0. Then we move on, like static route has an AD value of 1 and so on, where EIGRP has an AD value of 90. This is your feasible distance. This is via the next hop IP address. So these are the information. So if I say show IP EIGRP neighbors, such a important command to troubleshoot EIGRP. So if 2 routers does not become the EIGRP neighbors, then this is definitely the one which you would like to look for. It is telling me that I'm running the autonomous system number 200. S stands for handle here, which simply means that how did I learn the neighbors. So this is like 0 will be the first neighbor, 1 be the second neighbor, and so on. This is the IP address on which I have the neighbor relationship. This is my interface, on which interface I have the neighbor relationship. This is my hold down timer, which is 15 seconds by default in EIGRP world. So all the EIGRP running routers sends hello messages every 5 seconds out of all the interfaces. So if a router will not listen to the hello for the three hellos, so if a router missed 3 hellos, it means it will assume that my neighbor is down, and it will remove the routes from its routing table. Smooth round trip time, how long will it take to go to a neighbor and come back? So EIGRP uses this timer for the acknowledgement purpose, that when a router will send an update, it has to wait for an acknowledgement to come back. Retransmission timeout, how long do I need to wait before retransmitting a packet out, which is in always in milliseconds. Queue count, how many packets are in queue. So you must never see any packet in queue. If you see the packets in the queue count, there is definitely something wrong with the EIGRP neighbor relationship. This is your EIGRP sequence data bit. So very important command to know about EIGRP. So now let's go ahead on router number 3 and configure EIGRP there also. So I'll go to the global configuration mode. I'll say router EIGRP 200. I'm going to disable automatic summarization, and I'll say network will be anything starting with 192.168. Please advertise that, and anything starting with 10.1.2.0, advertise that into the EIGRP process. Now that's it. Let's go on router number 1 and make sure that we can show IP EIGRP neighbors. So I must have 2 neighbors, which I do have, because router number 1 has router number 2 and router number 3 which has 2 neighbors. Now let me say show IP EIGRP topology to see that what is happening. So first of all, you can say that these are the codes. So P is passive and A is active. Passive is good where active is bad. So I need to see passive in front of every network in the topology table, which simply means that everything is stable and running well. If you see active, it means router is actively trying to find out the backup path to reach a particular destination, but it is not able to get that. So it is telling me that to reach a network 192.168.10.1.2.0, I have one successor. It means I have one best path. The feasible distance of that successor is 1051.44.32. Now by looking on the topology, we can tell that if router number 1 would like to reach 10.1.2.0 network here, it has two possible paths. It can go via router number 2 or it can go via router number 3. But due to the metric calculation of Eigrp, router number 1 is going to choose one best path to reach a particular destination. Other paths will simply be the backup path, which is used if your primary link will go down. So in this output you can see that I'm going via 192.168.1.2 because the feasible distance which the successor feasible distance is the same, where this is your advertised distance. So this is your backup path. So router number 1, so who is 192.168.1.2 is actually router number 3. So router number 1 is going via router number 3 to get to 10.1.2.0 there. So very important command again to get there. So that's it, I guess. So we have achieved the first goal. Let's read the second point. Company security policy says that Eigrp running routers should not send the hello packets out of the interfaces where no other routers exist. So by default, Eigrp will send hello messages out of all the interfaces which you are running on. So it means router number 1 is sending hello messages to out of these loopbacks as well, and router number 2 is also sending the hello message out of its fast Ethernet link. So we can say that when router number 2 or router number 1 is sending hello messages out of the interfaces which we don't need, is actually a security concern. So anybody can take its own router and he can plug his own router to switch number 1, and he can make the neighbor relationship between router number 2, because remember, the number 1 key point for two routers to become neighbor in the Eigrp world is to exchange the hello packet. So if router number if router number 2 is still sending that, so he can do all kind of damage to the network. So the security policy says that these routers should not do that. So we can achieve this by using the passive interface command on router number 1 and router number 2. So first of all, let's make sure that router number 1 is sending hello messages out of those loopbacks. So I can say debug Eigrp packets hello. I just would like to focus the hello message on those. So you can say that I'm sending hellos on all these loopbacks there. Let me say undebug all to stop the debug of the Eigrp packets. Now I can go to the global configuration mode and I'll say router Eigrp 200, which is your autonomous system. I'll say passive interface default command, which will make all the interfaces as a passive interface, and then I will say no passive interface serial 1/0 and no passive interface serial 1/1, because I don't want these two serial interfaces to become passive, otherwise there will be no neighbor relationship. So that's it. Now let's try it again. Let me just say no service timestamps so that we can see our debug more clearly. So I'll say debug Eigrp packets. I'm going to debug the hello again. So now router number 1 must not be sending hello messages on these loopbacks, which it is not. So it is only sending or receiving hello messages on its serial interfaces, but not on the loopbacks. So awesome, cool. So we have achieved that. And on router number 2, I'm also using a loopback interface there, which I need to make the passive. So I'll say configure terminal router Eigrp 200, which is your autonomous system number. I'll say the passive interface is going to be the loopback 0. So router number 2 will also not send any hello messages out of the interface where no other Eigrp routers exist. So good, great. Let's move to the next step. Configure all Eigrp running routers in such a way that all the packets must be secure when exchanged between the routers. It means by default Eigrp running routers will exchange the updates which will not be secure. So anybody can sniff the data from in between and he can do all kind of damage to the network. So we want to make sure that when Eigrp routers are exchanging the packets, they must be authenticated. So for that we can use the authentication. So now first of all, Eigrp only supports MD5 authentication, where RIP and OSPF supports both MD5 and the plain text authentication. So you have to make sure the key number must match and the password must also match to successfully authenticate it between two routers. So you can't have the different key numbers configured on different routers. This is simply not going to work. So you will have the authentication mismatch in that case. So in lab they did not say that what Eigrp key number or what keychain name we must use, so we're going to use whatever we want to use. So let's go on router number 1 and I'm going to say go to the global configuration mode. I'm going to say keychain. I'm going to create a keychain name called, let's say, Eigrp. We'll use a key number of 10 and let's say the key string is going to be Cisco. Now, so once I create the keychain, now I have to go to the interface. Let's say interface serial 1/1 and I'll say IP authentication mode Eigrp and then your autonomous system number and what authentication mode do you want. So I want the MD5 authentication, which is the only one which Eigrp does support, and then I'll say IP authentication keychain Eigrp. I need to put the Eigrp AS number, which is 200, and then the word of my keychain, which is Eigrp. That's cool. Now if I say show key chain, you can verify it. So now you can see that I have the keychain configured Eigrp. This is the name, this is my key number, and inside the keychain I have a password of Cisco. I'm accepting lifetime and send lifetime is right now valid, where accept lifetime is when should I accept the keys from my neighbors and when do I need to send the keys to my neighbors. So Cisco is so cool in its authentication so that you can configure the authentication based on the multiple keys, where you can tell the routers that okay, for this particular month I would like to use key number 10, where for the next particular month I would like to use key number 20. But for that to work fine, you have to make sure that the clock must be synchronized on all the routers. So you must be using NTP, which is network time protocol, to make sure that all the routers has the same time or same clock. Otherwise, if two routers has different clock, then they will be sending the keys at different time, which will be again the authentication mismatch. So Eigrp can support multiple keys, but here we're going to talk about the single key only. Now if I say, so I need to put the same, I'll show you a bonus command here. I'll say show IP Eigrp interfaces detail, which will also tell you that authentication, whether you're sending the authentication out. So right now I'm not doing any authentication on serial 1/0, where on serial 1/1 I said that authentication mode is MD5. So let's go on interface serial 1/0. Let me say do show running config interface serial 1/1. I can just copy the configuration from there and I can put it here. So I need to just copy these two commands and put it there. So now if I hit the up arrow key, show IP Eigrp interfaces detail, now you can see that I'm doing authentication on both the interfaces. So my authentication mode is MD5 and my keychain is Eigrp. So let me say show running config, because I have to put the same commands on all the routers. So I'm going to copy the keychain configuration, which is this one. My keychain is Eigrp. I'll go on router number 2, go to the global configuration mode and paste this. Now I'll say okay, my so I'll say config t again, interface serial 1/0, and then I need to say what will be the configuration under the interface. So I'll say show running config interface. I would like to look for the serial 1/0. I have to copy these two commands and I'll paste it there. So now once I do that, my neighbor relationship must come up, which it is, and now I need to configure the same under the interface, which is going to the fast Ethernet 2/1. So on router number 2, I have configured authentication on this interface. I need to also configure it on fast Ethernet 2/1. So let's do that. So I'll say interface fast Ethernet 2/1, and I'm going to paste the same configuration there. Sorry, so it's like interface fast Ethernet 2/1. I'll say IP authentication mode Eigrp 200 MD5, and we'll say IP authentication keychain is Eigrp 200. My keychain name is Eigrp. That's it. Now let's do the same thing on router number 3. So I'll say show running config. I'm going to copy the keychain configuration. I'm going to paste it in router number 3. So we'll say that's it, and then I'll go to the serial 1/0, and I'll paste those two commands. So let's copy it from there. I'm sorry, I'm just jumping on the different windows to make sure that everything goes fine. I hope you get the idea. You have to configure the same commands on all the routers so that they can support authentication. So on router number 3, on serial 1/0, and the same story will go on serial 1/1. So we have to do that, and one more, which is fast Ethernet 2/0. Now my neighbor relationship must come up if my authentication is correct. So let's go back on router number 1, and let's make sure that if I say show IP Eigrp neighbors, I need to see 2 neighbors, which I can. So if I can see all the neighbors again up, it means your authentication is working fine. You can even say debug Eigrp packets, where you will be able to see that I am receiving the packets with the MD5 authentication where my key ID is 10. So this is another way to make sure that authentication is working fine. So now all the routers are sending the updates with the authentication, which is perfect and great. Let's go ahead with the next. We have come on a point where we will talk about the troubleshooting now. So last evening a network engineer has configured Eigrp for the new location, but there is no neighbor relationship between the routers. So as a network engineer, we have to troubleshoot it and make sure that they both form the neighbor relationship. So this is my new location where so I need to go on router number 4 and let's see what's happening. So let's go on router number 4, and let me just quickly change the color settings here so that we can see it better, and then we'll say that the color which we want is this one. So here somebody has come to, let's say show IP Eigrp neighbors, first of all, to make sure. Okay, so there is no neighbor relationship. Let me say show IP interface brief. Let's make sure that my interface is up and up. Let me make sure that I can ping to the 3.1, which I can. So this is to 192.160.3.1 here. Now let me say show IP protocol command to make sure that we are running the so I'm running Eigrp process 2000, which is not good. I mean, rule number 1 in the Eigrp world, that if 2 routers want to become neighbors, they must be in the same autonomous system. So we have figured out that the autonomous system which has been configured on router number 4 is not correct. So let's go and put the right autonomous system. So I'll say no router Eigrp 2000, which is not the right autonomous system. I'm going to put router Eigrp 200, which is the right autonomous. I'll say no to summary, and then I'll say my network will be 192.168.3.0, and I think that's it. If I say show IP Eigrp neighbors, still there is no neighbors. So let's go on router number 3 and make sure that we have the network statement there. So if I say show IP protocol, I'm doing routing for this network. So if I say show IP Eigrp neighbors here, I don't have any neighbor relationship because we are doing the authentication as well. So you have to make sure that you do authentication on all the routers. So let's do that. I'm just going to copy this configuration. I'm going to paste on router number 4, and under the interface level, so let's make sure do show IP interface brief. What is the interface? This is interface serial 1/0. I'll say IP authentication mode EIGRP 200, and I'm going to use MD5. IP authentication keychain EIGRP AS number is 200 and my keychain name is EIGRP. So once the authentication is perfect, now the neighbor relationship must come up. So that's there. So if I say show IP EIGRP neighbors, sure enough I have this neighbor relationship. And if I say show IP route, I'm learning all those possible routes from all the networks. So awesome. So this is how you troubleshoot the EIGRP network. You have to make sure that they are in the same autonomous system, they have the same key values, they have the same authentication going on between them, they don't have any passive interface configured on the interface. So that's it. Now finally I would like to review with these commands, which is the EIGRP commands. So show IP route, we know, used to check your routing table. Show IP EIGRP neighbors will make sure that how many neighbors do we have. Show IP EIGRP topology, which will show you all the possible networks which you have and all the possible paths to reach a particular network. Show IP EIGRP interfaces detail, which will show you the authentication and all the possible details about the EIGRP running interfaces. Show IP route EIGRP, which will only show you the EIGRP routes, which is used to filter the routing table. Show IP EIGRP neighbors detail, so it will show you the neighbor detail. You can debug EIGRP packets if you want to troubleshoot EIGRP. And finally show IP protocols, which will show you which routing protocol are you running on a router. So finally let's do one more thing. I'm just going to make sure that the route number 1 will take the backup path to reach to that particular network. So right now route number 1 is going to is using 192.168.1.2, and we can verify it. So if I say ping to 10.1.2.1, and if I say trace route to 10.1.2.1, router is taking 1.2, which is the router number 3 to get there. So because this is the primary path, what will happen if primary path will go down? So let's go to the global configuration mode, and I'm just going to shut down the link. I'll say shut down, link goes down. If I say show IP route EIGRP, now you can see that to reach that particular network it has jumped to the route number 2, which is 2.2. So if I say trace route 10.1.2.1, sure enough it is going to 192.168.2.2. So EIGRP is so quick, when the primary link goes down it will automatically switch over to the backup link. Whew, that's it. So I hope this has been informative to you, and I would like to thank you for viewing it.